Hello and welcome back to the Making a Model Organism Database webinar, Part 2, Editing the Database. Once again, I'm Alexander Scherer, speaking for the Bioinformatics Research Group here at SRI International. This part of the webinar series is going to run a little on the long side, so we're chunking it into smaller units. They're all part of Part 2, as it were, but you'll be able to download them all individually as you go through. Okay, so in Part 1, you generated your model organism database, your pathway genome database, using the Pathway Tool software and the pathologic component, and we guided you through that. Now in Part 2, you have this database, you're going to want to edit it. So let's take a look at how you do that. I'm going to talk a little bit about general editing strategy before we go back into the worked examples using the software. So the first thing you want to think about is, what's the focus of your database? A lot of groups running a database have a specific interest, and maybe you're working on a model organism that's mostly involved in one subject area. Maybe your focus is primarily genes and gene products. On the other hand, it could be metabolism, transcriptional regulation, an amalgam of all of the above if you're working on a model organism that's used for all those areas. Then after we talk about that a little bit, I'll have a little word on finding information, although we're not going to talk about that too much since it's such a broad topic. So say you're editing with an eye toward genes and gene products. And by gene products, I primarily mean proteins, although you should end up with some RNAs as well. It'll be largely whatever's in the annotated genome file, frequently ribosomal RNAs, tRNAs. So the first thing you want to do is check all the assigned names. Is everything what it should be? And you can do this in a systematic way, or you could look at your specific genes of interest. It's useful if you have a big file that lists all just the gene names by maybe individual gene number, however it's done. You can potentially mass import certain features, and I'm not actually going to go over the import-export function, but it's described in the documentation that comes with the Pathway Tool software, and it lets you, say, export a bunch of protein frames, add something in a systematic fashion, and then re-import them. And finally, I should mention that Pathway Tools expects you to curate proteins. And by this I mean that there's a lot of information that intuitively people tend to put either in genes or proteins, and it kind of goes with your background, whether you're gene or protein centric. But for example, we've set up the different fields and the features of the frames so that the enzyme activity and a long summary about the protein and most of its citations, and see I said the protein, will go in the protein page rather than say on the gene page. And this can occasionally confuse people who are very, very gene-centric, where you go to the gene page and think, wow, not only, say on BioCyc, is there no information here, on my own database, there's not a lot of space to put that information in. And that's because we expect what this thing does, functional information, to go in the gene product, primarily proteins, but also RNAs. If, on the other hand, your focus is metabolism, then you're going to start from a slightly different tack. You're going to start by cutting incorrect pathways. As I mentioned in Part 1, we err on the side of overprediction. And as such, you can expect to see some pathways there that don't make sense for your organism, that you think don't exist. Maybe it's the wrong version of a pathway. And so you'll start by going through and just deleting those frames. And you can just freely delete pathway frames wherever you want. Then I recommend checking MetaBioCyc for pathways. You're going to want to see if there are pathways there that for whatever reason weren't predicted, but which you look at, you know they're in the organism, you want to import, and that's a fairly straightforward process. Finally, checking elsewhere for pathways. Say you've looked at the database we predicted for you. You've looked at MetaBioCyc. You don't see the pathways, some of the pathways, it probably won't be that many that you think should be there. Then you can look to an outside resource, decide they're there, and then you're going to have to generate the pathway yourself, which we'll explain how to do later. However, there's a big caveat here. Your vision of the pathway may not match what we have in MetaBioCyc. We've made specific decisions about how big our pathways are, how we separate larger pathways because they have different variants in their components. You may go looking for a pathway by a name you know, for a certain structure of pathway that you know it by, and we may have it, maybe it's split. You have a 9-step pathway and we have it as a 5-step pathway and a 4-step pathway. So what we recommend is that you start with a molecule or reaction that you know is involved in your pathway of interest, go into MetaBioCyc, Start with that molecular reaction and browse from there. You may find that we have the pathway you're interested in, just not in the form you're used to seeing it in. Your interest may also be heavily focused on transcriptional regulation. Maybe that's why you study your organism of interest. Now this is going to be a little labor intensive because we predict transcription units, basically operons, but we do not even attempt to predict transcription factor relationships. It's a harder problem and would have more false positives than we feel like shoveling onto you guys. So just keep that in mind. It's going to be a lot of work, but actually manually curating any organism to a really extensive level is a lot of work. So the first thing you're going to want to do if you're looking at transcriptional regulation is validate the predicted transcription units. We will have predicted transcription units for you, most likely, if you decided to do that in step 1. And you'll want to go through and make sure they fit what you know. Then you can change them. You can change participants. You can change start insights. You can delete them completely. We'll talk about all these a little later. Then you want to add in known transcription units that maybe weren't predicted. And again, we'll talk about how to do that later. Then you're going to add in known regulatory relationships, so things like transcription factors. And again, we'll address that later. And now, before we get started on the worked examples, a quick word about finding information. So how you go about finding information depends on your organism and your focus. We naturally go to PubMed all the time. One of the advantages of working through PubMed is that our software is set up to link out to PubMed citations. So it's very straightforward to include PubMed citations. We'll link you out to the appropriate abstract, which is very, very clean. We also go out to general resources like Uniprot or PDB, and you'll probably want to go out to organism-specific resources for your model organism of interest. And that's about as much as I can say on it right now. It's sort of our general hierarchy of things, and the take-home message here is that it's very straightforward to link out to PubMed abstracts. Okay, with all that said, now let's go on and take an actual look at using the software to edit and create different parts of a database. And we're going to do this in order that's sort of easy for introduction to you, but doesn't really pertain on how you actually have to edit it. We'll look at reactions, then proteins, then pathways, then genes, then transcription units, and then finally transcription factors. And I'll welcome you back on the next video when I'll start by taking a look at reactions.